What going on, team? It is your friend Austin here with AP Space, and today we're going to configure the USART DMA Photon 1 V1 loopback software. So to begin, we're going to open up the STM32Cube IDE. We're going to go to File, New Project. You're going to type in our part number. And we're going to select yes on default configuration. And we are going to go to File, Save Project As. Then we want to save this project in whatever folder you would like to save to. So in this case, we're just saving it to the Loopback 3 folder. Okay, so we have our project saved now. And then what we want to do now is reference our other pre-made projects to guide us along the way. So on System Core, we go to System, we go to Debug, and we select JTAG 5 pins. And then we want to go to Connectivity, and then we want to enable USART 1 to the asynchronous mode. And we want to enable USART 3 to the asynchronous mode. And then what we see here is our pins are slightly altered. So our USART 3 TX and our USART 3 RX is going to change to PC10 and PC11 is where we will place USART 3 TX and RX. And then what we want to do now is make this 216 for the clock. And then our USART 1 is going to be our output. So we want to go to DMA settings, add, and then USART 1 TX on that. And then enable our USART 1 global interrupt. And then we'll go to USART 3 DMA settings. And then we could go to add, and then add the USART 3 RX. And then you can leave this as the default configuration in the DMA settings. You can go to the NVIC settings and then enable the USART 3 global interrupts. And then we can go to USART 3 parameter settings and change this to megahertz baud rate. And then we should change this to 2 megahertz baud rate. So that can remain the same, and then we should have everything configured correctly. Our pinouts all look correct. And then one more note is that make sure you put your clock configuration to 216 megahertz before you overclock your baud rate to 2 megahertz, and make sure that the primary clock is edited before you edit the baud rate to 2 megahertz, or else it will not work. Okay, so then we go to MDK ARM, and we save the projects. Okay, that should all be fine. And then we can generate the code. Like to do now is reference our previous heal project, and then we go to the main.c for our new project, and what we would like to do is go to our user code begin 0, and then copy and paste to user code begin 0 in our new project. And we go to user code 2, user code begin 2. User code begin 2 is here. Then we go to copy and paste. And then in the while loop, all we need is these 2 lines for the transmit. And then put it in user code begin 3. And then that should be all we need. And then we're using the direct memory access on the transmit and the receive, and we're sending 8 bytes at a time here. And then when we're receiving, we're processing all the data 1 byte at a time when we initialize the DMA on the receive, and also in our DMA function in our callback function. So we'll save that, and then we'll go to project, options for target, and then edit to use default compiler version 6. And then we'll save that, rebuild, download, go to debug. And then what we want to do now is highlight our array0rx variable. Add array0rx to watch 1. And then that should work just fine. So let's reset and then run. There we are, working just fine. And then you'll see all of that data going through the loopback. Then if we want to look at the data in memory, we can type in the memory address, and then we can see all of the data being transmitted into the NAND flash, and then our array 0rx array is reading the data and then placing the data in the NAND flash. So that is how you make the UART DMA software for direct memory access. You guys all have a wonderful day.